All right, for question number 2, we want to first describe the motion of the object from 1 to 10 seconds. So let's be clear. So from 1 to 3 seconds, that's an S, not a 5, it moves forward at 1 centimeter per second. Next, it moves, so from 3 to 5 seconds, it goes forward at 2 centimeters a second. And finally, from 5 to 10 seconds, we're going backwards at -1 meters a second. All right. Now the displacement of the object from 1 to 3 seconds, I'm going to color code this. I need to take the area of the graph. So once again, to be clear, please remember this fact, okay? The area of a velocity graph gives you the displacement. That's a very important fact to remember. We went over that in class, and here's your chance to review it. So I'm going to get and by the way, just to be clear, I need to be really careful about where I'm drawing my line. So here, the horizontal line that I want to use for this area is the 0 mark here, this axis here. The horizontal axis is right there. So when I'm taking the area from 1 to 3 seconds, it's going to be this part right here. Okay? So from 1 to 3 seconds, from 0 to 3 seconds, my area here is, this is 3, that's 1. And using the rectangle formula, the area is the length times the width. And that's going to be 1 times 3, which is going to be 3 centimeters. Now let's go ahead and get the total displacement of the object in the next part, which is part C. So I have a width of 2 seconds and a length of 2 centimeters. So I'm going to have here 3. So I'm going to have 3 plus 4 plus, I have this negative area down here. And if I look at this width, careful, the width goes from 5 to 10. So that gives me a width of 5, okay? From 5 to TO, that word, from 5 to 10. So that's a width of 5, and I times it by -1 since that's downwards. So 5 times -1, and that's going to give me a total displacement of, sorry, it's -1. You know what, I don't like I wrote that. So plus 5 times -1. And when I add that up in my calculator, just add it's going to be a total displacement of 2 centimeters. All right. And what I'll say here is C graph. Now let's go ahead and plot the position versus time, let's remember our rule from number 1. The slope of the position is the velocity. So these are velocities, and so what that means is that from 1 to 3 seconds, I've got a slope of 1. Now, I don't tell you where to start, so what I'll say is this. Start from 0. I know the speed is 1. That doesn't say anything about the position. Speed is 1, velocity is 1. Position will start at 0. And for 3 seconds, we're going to have a slope of 1. So I just want to line this up. From 0 to 3 seconds, reading the velocity graph, the slope is 1. From 3 to 5, the slope is 2. From 5 to 10, the slope is -1. So so 3 to 5, the slope is 2, and from 5, oh my gosh, it's terrible, from 3 to 5, the slope is 2, and from 5 to 10, the slope is -1. I'm just reading this. This is all from the velocity graph. This is all velocity graph data, and I'm going to graph it here. So for 3 seconds, I'm going to have a slope of 1, so over 1, up 1, over 1, up 1, over 1, up 1, like that. Then I have from 3 to 5 seconds, I have a slope of 2, so over 1, up 2, over 1, up 2. And then for 5 seconds to 10 seconds, I have a slope of -1, so over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. And I connect the line at the end like that. Notice something. Here's a little check in our graph. We calculated the displacement as being 2 centimeters from the area. Look at this. X final is 2, X initial is 0. So just a little confirmation there that the displacement here is still 2. It matches our graph up here, and we're good. So that's question number 2.